Hi, we're going to look at absolute value and quadratic inequalities. And most of what we're going to do is just be by looking at the graphs of these functions. So for number one, just kind of trying to understand what it means to be less than or greater than. What we're thinking about is looking at a function like f of x, and we're talking about when the y values are less than 0, or in other words, negative. And so we want to darken those portions where our y values are negative. So I'm going to highlight those sections. We're talking about everything here, here, and then we want to talk about those sections that are greater than 0. So greater than 0, we're talking about our y values being positive. And so that's just going to be above the x-axis. So we already got used to setting things equal to 0, like our quadratics, and trying to see where it equals 0, these parts right here on the x-axis. And so now we're looking at where we're above it or below it. So for what x values are we actually equal to 0? That's happening when x is -4, -1, 2, and 5. Those were the yellow highlights that I have here. And then for what x values are we less than 0? Again, those were our little red sections. So that's talking about from an x value of -6 to an x value of -4. So at -6, we are below, all the way up to -4. Well, now we're on it. We're going to put a parenthesis on this one because it just has strictly less. So at -4, we equal 0, so we can't include it. And then we also have, starting from the -1 to 2, from -1 to 2, both of those not included because that's where we equal 0. Then the part where we're greater than 0, that's looking at those green sections. So again, the important numbers are going to be where we equal 0. So we're saying from -4 to -1, those are both parentheses because we equal 0 at those points, and we want to be just greater than 0. And then from 2 to 5, and I'm going to put a little U to say both of those sections. And again, that was looking at the green highlighted section. So let's look at an actual absolute value function. So we're looking at absolute value, just a regular parent function. So remember, that's our v, so it's going to be going up like this, and then we're going to graph the function g of x equals 3. So we're talking about this guy right here. And so the first question that it has is, when do the functions really equal each other? So we're looking at where they equal each other. Well, that's going to be right here and right here. Now, I said we most of the time will compare with 0. Sometimes it'll have a number there, but we can see when that's happening. Now, my graph isn't the best because I didn't draw my straight line, but what's going to happen, if I would have drawn it a little better, is that's going to be happening at -3 and 3. Just if you think about it, the absolute value of what equals 3? Well, x could be, again, 3 or -3. So you can see how that matches up with the graph and how we were solving the absolute value equations before. So our new question is, where are we above and where are we below? So when I'm looking at the part where it's less than 3, so that means where is our v below that y value of 3? So it's happening right there, and that's between -3 and 3. We're below. Then we're looking about where we're above, where we're greater than 3. So that's going to be the upper part of our v, and that goes forever in both directions, to the left and to the right. So that's going to be from -infinity up until we get to -3, union 3 to infinity. So remember, we're going to be emphasized on that point, but this goes forever to -infinity, and again, emphasized on that point, but it goes forever to infinity that way. All right, let's get a little more complicated absolute value here. We have a transformation. It's moving to the right one space. So the same exact v, move to the right one space. Let's see what happens with that one. Again, we've already solved the equations. So let's see, if g of x equals 3, you can see the two answers like you would have expected. So we're happening here and here. So if I drew my graph right, it looks like this should be happening at -2 and +4. So if I want to check, I could just kind of plug in or think about how we solved these before. When does x minus 1 actually equal 3? And when does x minus 1 equal -3? So if I add 1, you get the 4, which is what we had there. And then if you add 1 over here, we get the -2. So my graph looks pretty good. So those are like my important points where I change from being above or below. So when I switch over right now to talk about where I am less than 3, that's the part below, less than the line, I'm below. And so I'm between the -2 and 4. So that's between -2 and 4. Then when we switch and talk about being greater than 3, that's the above part. So those are going to be those two separate branches. And those guys will go from -infinity to the -2 and then start over again at the 4 to infinity. So if we want to predict how we can use algebra to solve these inequalities, look about what we're really trying to do. We need to know where we are equal to that thing first, and then really it's about checking if we are below, which would be the less than, or if we are above. So let's see. On these ones right below here, they're the same question that we were just asking. And again, what I'm saying is we really want to see just what's the actual solutions to the absolute value equation. So that's saying our little blob here is either 3 or it's -3. And so I always like to refer to the graph. And so as soon as I get these two values, I know I'm talking about a v, and I know that the 3 is somewhere in there, and I know that this is like -2 and 4. So if I'm asking this first question being less than 3, I know I'm below, so I'll just say from -2 to 4. For the second one, I'm greater than 3. So again, for this part, I know that I'm above. So that tells me the -infinity to -2 union 4 to infinity. And it will always work like that. So if we can solve the equation, then we can solve the inequalities. So some people like to kind of memorize something, and this one isn't my favorite, but I'll write it based off of what we have just noticed. But if we're talking about the absolute value of something, and I'm still drawn to my v, and we're being less than, okay, then it's equivalent to saying that the inside part is either less than the k, so less than the k, so this would be where our k is, and then this is going to be our -k. So that means that our inside is greater than -k. A little bit better way to say that is that our inside part is sitting between -k and k. So just to make sure that this is right, -k and k, it looks like it should be in that order. Now for the greater than part, again, I'm still needing to know where we are equal, so like -k, but I want to be greater, which is those outside sections. So this is equivalent to saying that my inside is bigger than k, which will put me here, bigger than k, or my inside part is this way, less than -k. And these words should be kind of familiar to what we had seen before when we were solving compound inequalities, the and the or. So we're going to skip over to number 5. We're going to do another one by graphing and using the algebra. So the first thing we have is a graph that has been transformed. This has a reflection over the x-axis. We have a shift to the right of 2, and then we have a movement up 4. So that's what's going on with the left side of our inequality. So I'm going to move to the right 2 spaces, up 4, and then I'm pointed downward because I had that reflection. And these are nice, they're supposed to be straight lines here. As best I can make it, and it's going to keep going. And then on the other side I have a 1, so that's going to be right here, y equals 1. And so you can see where I'm touching right here and right here, which matches up with a -1, and 1, 2, 3, 4, 5. That should be a 5. So it looks like if I'm talking about the equals, like if this was not an inequality but equals, would be -1 and 5, but I want to be less. So I am less all the stuff down here and here. So that's going to be from negative infinity to negative 1, union 5 to infinity. Now this one might feel a little different than what we just saw because we have that upside down v. So if I'm going to solve just by using algebra and not actually making the graph, it will look slightly different. I'd actually try and isolate the absolute value. So I'd have negative absolute value of x minus 2 is less than negative 3. What we've seen is if there's a negative in the front multiplied, we would divide by negative 1, which really flips us the sign of our inequality. So it will now be greater than, and that will become a positive 3. So then again, we're talking about a v. Now there's no negative there, so just in my head, I'm visualizing a v and then a line going through that v. And I want to find out where those points are. So this will feel a little bit different. To solve the equation, when does the absolute value of x minus 2 equal 3? It's when either x minus 2 is 3 or x minus 2 is negative 3. So if I add 2 over, I get x is 5. Add 2 over, I get x equals negative 1. So this is happening at negative 1 and 5. And so then I'm going to look at my inequality that we're talking about here, and it says where we're greater, which would be the sections up above there, which will match up with what we said over here. It's going from negative infinity to negative 1, union 5 to infinity. Okay, we're going to try and solve these last 4 absolute value inequalities. So you should kind of pause it and try and solve them on your own. You're not going to have to graph them, but you can still visualize a v. Okay, now that you've tried, let's see if we can figure these guys out. So I have an absolute value, so I'm thinking about a v, and then I want to look at it compared to 8. So 8 would be somewhere going on in there. So I know that I need to find out where these two guys are touching. So I want to solve the equation. When does absolute value of 3x minus 1 equal 8? That's the question. So either 3x minus 1 equals 8 or 3x minus 1 equals negative 8. If I add 1 over, I get 3x equals 9. Divide by 3, that happens when x is 3. Over here I add 1, we get 3x equals negative 7. Divide by 3, we're getting it happens when x is negative 7/3. So I know this point over here is going to be the negative 7/3 because that's less to 3. Now looking at the inequality, it says where are we less? That would be all these values down below. So we're going to say our answer to this will be from negative, let me erase that, from negative 7/3, not including it because we don't want to actually equal 8, over to 3. That will all put us down below. For part B, we're still asking for absolute value, so I picture a v, and I'm going to compare with 9. So again, I want to find those intersection points. So I want to know when the absolute value of 2x minus 3 is equal to 9. So that happens when either 2x minus 3 is 9 or when 2x minus 3 is negative 9. So solving these guys, I get 2x equals 12. Divide by 2, we get x is equal to 6. On the other hand, if we add 3 to both of these, we get 2x equals negative 6. Divide by 2, and we get x equals negative 3. So the points are negative 3 and then 6, so a little and then big. Now this time, we want to talk about where we are greater than or equal to 9. So the greater than stuff is going to be above, and it says equal to, so we can actually include those endpoints now. So in interval notation, since it goes forever left, forever right, we're going to say from negative infinity to negative 3, close that up, union, we're going to go from 6 to infinity. And so that would be my solution to the inequality. All right, for part C, again, I have an absolute value, so I'm going to make that. And then it says greater than, now this time it has a negative 10. Now this absolute value is positive. There's no negative reflecting it or anything. So we need to think about this for a minute. It says, when are we greater than negative 10? Well, negative 10 has to be down below somewhere because absolute value is always positive. And so if we look at this question, it wants us to say, when is this absolute value greater than or equal to negative 10? So when is it above? It's above all the time. So this is actually a special one where we're going to say it's going to be all the time from negative infinity to infinity. For part D, This time we have absolute value, but there's a little negative hanging out in the front. And so we know that this is going to be upside down. And so it's always going to be a negative value here. It's not being shifted up or anything. So then the 6 is up above here. So look at what the question says. We want to know when we are greater than or equal to 6. That would mean above. If you look at this, we're always down below. So this can never happen. And so there is no solution to this guy. And you know one of these weird cases is going to happen if you aren't quite sure about the graph, because if you actually go and solve the equation, you'll see that there's no solution. So if I set up the equation, look what we're saying. The absolute value of something equals -10. That can never happen. There's no solution to that. Similar to over here, if I put a negative in the front there, I have 3 minus x over 5. If that is equal to 6, I would divide by a -1, divide by -1, and we have 3 minus x over 5 equals -6. Again, this can never happen. We're never equal to it. So then you have to just figure out, are you living always above or always below, which is what we have seen. Okay, we're going to move over to number 7, which is looking now at quadratics. And so it's going to be really similar to our absolute value, except we almost always will compare our quadratics to just 0. So we have x squared minus 5. That's a parabola that has been shifted down 5. So I'm going to mark that on here. So there's my function f of x. And then we have our g of x, that's -1. So it looks like it's right here. And so we want to see where we are equal. And so my graph, not that good. It looks like a -2 and 2, maybe. So -2 and 2. So if I want to actually check, I can actually solve this. Set this equal to -1. So I can add 5, add 5. So x squared equals 4. I square root, and yep, I'm right. It's going to be 2 and -2. Or you say plus and minus 2. And so again, it's asking us those same questions. When are we less than -1? That would be everything below. So everything between -2 and 2. And then it's asking, when are we above? And that's going to be the 2 intervals from -infinity to -2, union 2 to infinity. So if we're going to predict how we can use algebra, basically we need to set our quadratic equation equal to 0 and see if we are above or below. So it has a setup for us right here to do it without the graph, but I'm still going to picture, when is x squared minus 5 equal -1? And so we get that x squared is 4, and that happens when x is 2 and -2. So to solve both of these, I'm going to imagine that I have my graph of my parabola, and I want to see, this is -2 and this is 2. I want to see where I am less, which would be that part, or -2 to 2, or where I am greater than 1, which is those above parts. Again, -infinity to -2, union 2 to infinity. So it's like every time I'm drawing the graph, but I don't have to be so specific about where all my points are and everything, except for finding the 2 intersection points. And then I just determine if I'm above or below. And so you know that you're going to have either 1 or 2 intervals depending on if it's less than or greater than. So if you're under, that's the portion down below, that's where it's only 1 interval. If we are above, again, it depends on our parabola pointing upward, we would have our 2 intervals. So if we had a reflection going on, we would have 1 interval if we were above like that, or 2 intervals, again, just looking at the other part. So it kind of depends on which way that you're flipping. Okay, so let's look at what we have here for number 8. We have our parabola shifted to the right 1 and down 1. And then we have the g of x equals 0. Well, that's just our x-axis, that horizontal line. So if we go to the right one, down one, and I'm going to draw the rest of my shape here, and then compared with the x-axis, you can see again where we intersect at. That's at 0 and 2. So we can see on the picture that's happening. We can also solve algebraically. X minus 1 squared minus 1. Well, when does that actually equal 0? Add 1 to both sides. I'm running out of space here. X minus 1 squared is equal to 1. You take the square root, we get x minus 1 equals both the plus and the minus 1. So that means x minus 1 is a positive 1 or x minus 1 is negative 1. So if I add 1, there's my x equals 2. Add 1, there's my x is equal to 0, which matches what we see on the picture. So again, as soon as we know where we equal that number, then we're just going to be looking above and below. So this is saying less than 0, that's below. So that's going to be everything between 0 and 2. Then we're going to look up above. So that's going to be from negative infinity to that 0 union to infinity. All right, we have a few more for you to try, so you should pause it and try parts A through D and then check back in. Now that you've tried, let's see what we can do. So we always want to compare our quadratics with 0. That's the easiest. So then we can solve the quadratic equations. We can solve that using any method. I always like to try factoring first, or you can use quadratic formula. We need to multiply to negative 6. That would be a 3 and a 2. And we need to add to 1, so that does it for us. So we know that we're equal to 0 at negative 3 and 2. So graphically, because I have a parabola pointed upward, I know I touch the x-axis at negative 3 and 2. So to answer the inequality, it wants me to know, well, where am I less than 0? It's going to be everything in there. So between negative 3 and 2, I am going to be less than 0. For the next one, I have negative x squared plus x plus 12, again, equal to 0. We might want to try and get that negative to go away. You can move everything to the other side or multiply by a negative. If I multiply both sides by negative 1, that becomes x squared minus x minus 12. It just looks a little bit more factorable. And then this will factor x and x, so that way we don't have to worry about that minus 1 at the beginning. We need numbers that multiply to negative 12. That will be a 4 and a 3, and add to negative 1, negative 4, positive 3. So that gets us x equals 4 and negative 3. So I know my parabola. Now this is kind of important here. If you're going to look at with the equal to 0 at this point or up above, I always like to look at my original guy. And when I look at it, I notice that there was a negative in front of the x squared. So this time I'm actually thinking about my parabola flipped upside down and touching the x-axis. And it's touching at negative 3 and positive 4. So then when I am asked the question, when am I less than or equal to 0? Well, less than 0 is going to be this downward part and also on the actual x-axis. So this time it's going to be from negative infinity all the way to negative 3, because this goes from negative infinity and then that goes to infinity. Include the negative 3 union, and we'll have 4 to infinity. For part C, I need to write it in the nice order first. So I'm going to plus the 15 over, keep the x squared positive this time. X squared plus 8x plus 15, and again compared to 0. So I want to see when this parabola is actually equal to 0. So I'm going to try and factor, which will work nicely. All these will factor. So we get x equals negative 5 and negative 3. So going back to the original, I'm going to actually look at this guy where I had it all on one side. I want to know where I am greater than 0. So I already know that I have a parabola facing upward compared to 0. And this is negative 5, that's littler than negative 3. And so I am greater than 0 up above. And so again, this is going to go from negative infinity to infinity. So I'm going to look at negative infinity up to negative 5, not including it because it doesn't say equal to in my inequality, union negative 3 to infinity. That would be my solution. Okay, there's one more here. I have 2x squared over here. I want to keep it positive, so I'm going to move the 7x and the 15. So moving that over, I have 2x squared minus 7x minus 15 is less than or equal to 0. So I'm going to try and factor it. Now it has a 2 in the front, so sometimes it might be a little bit harder to go to the parentheses. So I'm going to actually skip that for just 1 second. So I'm trying to solve when is 2x squared minus 7x minus 15 equals 0. So you can use the quadratic formula, or I could think about this. Again, 2 times negative 15, that's negative 30, negative 7. Numbers that do that would be 10 and 3, negative 10. So that multiplies to negative 30 and adds to negative 7. So remember that replaces the middle. So we write 2x squared, negative 15, but the middle is now negative 10x plus 3x equal to 0. So the first two have a 2x in common. I'm left with x minus 5. The next ones have a 3 in common. I'm left with x minus 5. So this factors to x minus 5 times 2x plus 3 equal to 0. So, I mean, I can just look at the first one, x minus 5 equals 0. That's when x is 5. Some of you guys can already do it with this, but if not, you can solve that. So that's 2x equals negative 3. Divide by 2. And so we're getting x equals negative 3 over 2. So what this means is that my original parabola going up here, this guy, which if I graph it, oops, undo, is a forward, or not upside, facing upward parabola. We're comparing to 0, and the numbers that we just got, negative 3/2 is where it intersects here, and this is 5 where it intersects there. And we are concerned with where we are less than or equal to 0. That's going to be everything below is less than, and then include those 2 points. So that's going to be from negative 3/2 included to 5 also included. So that's why those have the brackets as my final answer.